Hello, students. We are going to start with a complete revision of all the chapters for your board exams. We'll try to upload the videos almost every day, if not one day after, like every alternate day. Today, we are going to start with relation and functions, class 12. So let us just start. What is there inside the chapter? What is the content? And then we will definitely do the practice of all the questions, which are important questions. So let us start. For relation and function, plus 12, the contents are basically, there are only two things. One is relations and another is function. Now let us start today with the relation. The first video will be intending to clarify all the concepts and the practice of the problems of relation. In the second video, we'll take the function. It will be comfortable for us if we go one by one. So let us go for a quick recap of the concepts so that we can easily understand what exactly are the type of problems. Any subset of A cross B is called a relation on A to B. Any subset of A cross B is called a relation on A to B. We got it in class 11. Out of that, which is not written here, you can get the subset as phi, right? Phi is called empty relation. Already we got it, empty relation. Just for a quick revision, we are doing it. And then we can get even the complete subset A cross B. This is called universal relation. Universal relation. So these two are the spatial subsets, spatial relations. The number of relation from A to B is 2 to the power number of elements in A into number of elements in B. Because 2 to the power mn is the total number of subsets, possible subsets in the product A cross B. And hence, every subset of A cross B represents a relation. Therefore, total number of relation will be 2 to the power NA into NB. NA and NB are cardinality of the sets A and B. Fine. Then the third point, a relation from A to A. Now, just you try to see, we are going to have relations not from a set A to another different set B. We are going to have the relations from the same set to itself. So whenever we have a relation from A to A, we call it simply a relation on A. So by the word relation on A, you should be able to understand that we have a relation from A to A itself. Next, types of relations. There are various types of relations which we got in class 12. So let's have a look at those types. What are those? A relation R on a set A is called reflexive, right? A relation is said to be reflexive if for all elements A in capital A, that given set, it is related to itself with the conditions of the relation R. I'll take some examples. You will understand it. If A and A are related, A is related to itself, then it is called a reflexive relation. Symmetric relation. What is symmetric relation? It is said to be a symmetric relation if A is related to B under the relation R, and then it will imply that B is also related. That means it is related in the reverse order. Then we say that it is symmetric relation. And last, the transitive. Transitive relation if A is related to B is related to C, then A is also related to C. If this is possible, then we call it transitive relation. So these are the basic three different relation which we need to study in class 12. We have to attempt the questions on this. Now, before I go for the next, I want to take a small example so that you can clarify the concepts of reflexivity, symmetricity, and transitivity. I'm going to take the example here in this small part. Please see that. Suppose I'll take a very simple example first, then we'll be following the problems. Suppose you consider the set of natural number, right? And on natural number, you are going to define a relation. So you will say that A and B will be related. A and B will be related if A is greater than B. A is greater than B, where A and B are taken from the natural number. Now we have to check whether it is reflexive, right? So reflexive, if it should be, then I should be able to say that A comma A will be belonging to R. I mean, A is related to A. Now just check. If A is related to A, then what should be the condition to be satisfied? The condition should have been A greater than A. But is this possible? No. That means A comma A cannot be an ordered pair in R. It means A is not related to itself and therefore it is not reflexive. Okay. Then you talk about the symmetric. So for symmetric, you should start with one pair where they are related already. So I consider that A and B are related. Okay. If A and B are related, then I can say according to the condition that A is greater than B. Okay. A is greater than B. Will it imply B greater than A? No chance. If A is greater than B, B cannot be greater than A. If B cannot be greater than A, then will BA be in R? Not at all. So what does that imply? It implies that it is not symmetric. Now, in the third case, you have to consider A comma B belongs to R. It means A is greater than B. A is greater than B. B comma C belongs to R. That means B is greater than C. So will it imply A greater than C? Yes. That already we know. So it means A comma C is in R. So it is transitive. So in my simple example, when I consider the relation R in natural number, where the condition of relation is greater than, it is only transitive. It is not symmetric and it is not reflexive. Let's move on to the next. Under the types of relations, we also get a special kind of relation. And what is that? It is equivalence relation. Equivalence relation is a relation which is satisfying all these three types of relations condition. That means if it is reflexive, symmetric, and transitive, in that case, we call that particular relation an equivalence relation. But if a relation is not reflexive but maybe symmetric and transitive, it is not an equivalence relation. So, what example I discussed in the previous one is not an example of equivalence relation. I hope it is clear to you. The next very important point with reference to equivalence relation is that every equivalence relation on a set, on a given set, partition it. Partition it means divides it into equivalence classes. Now, how many equivalence classes will be there? With respect to the problems, we can get the detailed information. And in course of time, already you know equivalence classes, but whenever problems will come, I'll explain you. Move on to the next. Important points. These are very important points because, sorry, please hold on. Okay, these are very important points. These are not basically there in the textbook of Cbse, but even then, there may be questions, miscellaneous, multiple choice questions for this. So if you can be remembering it, it will be good for us, good for you as well. And of course, I have just written the formula. There are good deductions for it, not a difficult one. But as it is not required, I have just written the formula for you. So you try to remember that and try to use it directly when it comes. So what are those two informations? R be a relation on a set A. R be any relation on a given set A. Then number of reflexive relation. So if somebody asks you that a set is containing, say a set is containing three elements. So in total, how many different reflexive relations you can construct on it? That is given by 2 to the power n into n minus 1. So for a set containing three distinct elements, number of reflexive relations will be 2 to the power 3 times 3 minus 1, that is 2. That is, it will be 2 to the power 6, that is 64. So you can see a set containing three distinct elements will be having 64 number of reflexive relations. Then the next is about the symmetric. How many symmetric relations will be there on that set? It is 2 to the power n into n plus 1 by 2. So for this set, what is the total number of symmetric relations? It will be 2 to the power n, n means 3, then 3 plus 1 divided by 2. So it will be again 6. Okay, it is a coincidence. Okay, it's a coincidence that for this particular set, we have got equal number of reflexive relations and symmetric relations. But always it is not the case. So I insist you to remember these two formula so that you can apply it in the exam very directly. Now let us start with the questions. Dear students, we are going to take questions which are exam oriented. And I'm sure after going through this entire video and solving these questions, you'll be empowered and you'll be getting the exposure to various different questions which are likely to be set in the board exams, if not directly, but very close to it. So let's start. We are starting with the MCQs first. We'll solve it for you. You go with me, try to understand. If you'll be having any doubt, comment box will be open. You can definitely ask the clarifications. Some questions of these might be from the textbook or some are specially prepared for your exams. Earlier, of course, I'm talking about the PYQs. Let's have a look at this question. What is there? A relation R is defined on a set of human beings. What is the relation? R is given by x comma y, that is x is related to y, if x is 5 centimeters shorter than y. What is understood? X and y are two human. They are said to be related to each other if x is 5 centimeters shorter than y. So the idea is that y is taller than x. Now you have to justify which will be true. It's very clear that it is not possible. It cannot be in R. Why? Because one person himself or herself cannot be 5 centimeter shorter. So X cannot be related to itself. So reflexive only is not the possible case. Fine. So here also reflexive is given. So this you obviously you can rule out. It cannot be reflexive. Now let us go for the next two. Symmetric and transitive. Let's see. Is it symmetric? So let us start. XY. Okay, if XY is there, who is shorter here? X is shorter. Who is taller? Y is taller. So if I have to balance the equation, I have to add 5 to the shorter one. So my relation of xy should be x plus 5 equal to y. Great. Now, if I want to say that y and x, y is related to x, what should I get? I should get y plus 5 is equal to x. Now just think, can this result imply this? Not at all possible. Or a simple logic can be applied. If x is shorter than y, how can y be shorter than x? So this cannot be in R, right? This implies this cannot be in R. That means it is not symmetric as well. So here they are talking about the symmetric. So it is also not there. So now third one you can easily observe and you can see neither reflexive and symmetric nor transitive. So if you obviously you can check that it is not transitive also, but because this is the only option left, so it's the correct option. Okay. So correct option is D. That was the correct option. Now you come to the next question. A relation R is defined on a set A where it is 1 to 3. It is defined as 1, 1, 1, 2, 2, 2, 3, 3. Which of the following ordered pair in R shall be removed to make it an equivalence relation on A? You have to make it an equivalence relation. So what you must remove, they're not talking about adding. So some uh, ordered pair you must remove. So first of all, you try to recall what is an equivalence relation. For being equivalence, it should be reflexive first. So to be reflexive, you need to have 1, 1. So it is to be there. 2, 2. It is to be there. 3, 3. It is to be there. So which you have to remove? 1, 2. So this is your correct answer. This is your correct answer. Right? So it is a very simple question, 1 mark. So your correct option is B. Correct option is B. Okay. So let's go along. I hope you are going with me. Next is this question. Let the relation R in the set A. What is the set A? A is the set containing X belongs to Z. That means all X which are in Z, that means integers. But what kind of X? It is lying between 0 and 12, including both. Given by, what is the relation? A and B are related if modulus of A minus B is a multiple of 4. I think by reading the question, you should be able to recall that this is actually a question of your textbook, right? Okay, some little changes may be occurring here. Little changes may be occurring here because they are not directly asking whether it is equivalence or not. They are asking these things. And then, what is this box one? Box one means they are talking about the equivalence class containing 1. Now I'm going to tell you what is equivalence class. So equivalence class of an element means all the elements which are related to that particular element under that relation. So if I am asking you what is this box one, that is equivalence class of one, you have to talk to me about set of all elements, right? Set of all elements of whom? Of A related to one. Okay. So in A, what are the elements? You are going to take the elements in A as 1, 2, 3, 4, dot, 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 up to 12. Out of that, which elements are related to 1? That will constitute the equivalence class of 1. So what is the criteria of relation? Modulus of the difference should be divisible by 4. Multiple of 4 means divisibility by 4 will be there. Right? So can I say 1 is related to 1? I'm writing in this way. It's a rough representation because 1 minus 1 will give you what? 0. And 0 is a multiple of 4. So 1 is related to 1. Okay. 1. Then you try to see 2. 1 minus 2 is giving you minus 1. So it is not related. 1 minus 3, gap is 2, not related. 1 minus 4, difference is 3, which is not divisible by 3. Sorry, not divisible by 4, so not related. So this way you can inspect 1 minus 5. This will give you what? Minus 4, and it is divisible by 4. Of course, if you want to follow directly the conditions, it is better if you put the modulus sign. So it is divisible. That means with 1, the relative elements are 1 itself, 5 itself, and try to do the inquiry for more, little more. Which one will be there? 9 also, because 1 minus 9 modulus will be 8. Okay. Then the last element is 12. So 1 minus 12 is 11. Right? 1 minus 13, had it been 13, 13 would have been related. But here 13 is not there. So what are the three elements related? 1, 5, 9. So your answer is this. The equivalence class of 1 is, if in a descriptive question you have to write, so your answer writing style would have been this. So that is the answer. Check this. This is a very important question. I hope you have understood this. So your answer is option A. Great. Now you come to the question number 4. So I think this type of questions can be there also in board exams. So be very alert about that. You must be very, very clear. 1 to 3 is there. Maximum number of equivalence classes. Equivalence relation on A is. What is the maximum number of equivalence relation? Maximum number of equivalence relation will be how much? So total number of relations will be, I think there is something missing here. Maximum number of equivalence relations, because it must be symmetric, it must be transitive, it must be reflexive, right? So number of reflexive relations will be here. If I just count, I think there is a this may be a wrong question, but anyway, let us give a try. Total number of reflexive relation will be what? It is 3 into 2, 6, that is 64. So this many reflexive will be there. This many symmetric will be there. Then we have to think about the transitive, because you have to make it transitive also. No, there is something wrong here. It is not a correct question. I'm sorry, student. I have included this. Let's go for the next. Correct option is D. I think something is missing. I'll check it and I'll update in the comment box, right? Okay, let's have a look at this question. A relation R defined on the set N. N means set of natural number. What is the relation condition? Acha, it is set in 2023. In this question, the condition is that A should be equal to B minus 2 and B should be greater than 6. Then, out of this, which is the ordered pair belonging to R, or which is the true? So, one thing is very sure, you act clever. B should be greater than 6. So, very clearly, this will be ruled out. Because here the B is smaller. Fine. Then what is the relation between B and A? B minus 2 is A. That means if you subtract 2 from B and you get A, then they are related. So if you take this C option, 8 minus 2 will make it 6. So actually this is the correct option. So you got it. It is a easy part, but if you don't understand the question, it may be a problematic one. So your option is B. Your option is B. Please see that. It's a very important question. Easy but important. Okay. Now let us come to the next question. It is set in 2020. A relation R defined on the set A, which is 1, 2, 3, and this time given by 1, 2, 2, 1, and 1, 1, is what type of relation is? There are many options. Let us try to justify one by one. Very straight away, you can see that it is not reflexive. Why not reflexive? Because for being reflexive, you should have 1, 1, 1, 1 should have been there, then 2, 2 should have been there, and 3, 3 should have been there, all three, but they're not there. So it is not reflexive. So you ruled out where it is said to be reflexive. So B cannot be, and then equivalence relation, it cannot be. Two are ruled out. Okay, next you think about the symmetric. 1, 2 is there, 2, 1 is there. Fine, this is symmetric. That means symmetric is okay. Symmetric is okay. Now the last option is about the transitivity. So you have the ordered pairs 1, 2, 2, 1. So is this saying that 1, 1 is there? Can you find 1, 1? Yes, 1, 1 is there. So transitivity for these ordered pairs are satisfied. But if I write like this 2, 1, 1, 2, then is this applying or is this indicating that 2, 2 is also there? No, not there. You cannot find 2, 2 over there. That means transitivity for these ordered pairs are not satisfied. It doesn't imply. So transitivity is failed. So this relation is only symmetric, but neither reflexive nor transitive. So your correct option is C. It's a very good question, right? So please be very alert about this kind of questions. It's a very good questions, MCQ. So option is C. Fine. Go for the next question. I'm moving a little faster. So whenever you are doing the problem, I definitely want you to pause the video when you see a question and then you try to solve it from your side and then you see the solution. It will be more effective. Okay. Let set X is equal to 1, 2, 3. And the relation is defined on the set X as 1, 3, 2, 2, 3, 2. Then the minimum ordered pairs which should be added in the relation R to make it reflexive and symmetric. They're not talking about the transitivity. If it is not also, no problem. So you have to make it reflexive. So one by one you take reflexive and symmetric. So to be reflexive, it should be 1, 1, 2, 2, 3, 3. These three ordered pairs has to be part. So now just check which one is present there. 2, 2 is present. That means I have to add necessarily these two. So if I add only these two, I already have here which ordered pairs? 1, 3 and 3, 2. right? So these are already there in the given. I have added these two. Is it making it symmetric? Just see, because they are only asking about reflexive and symmetric. Reflexive is done. Now, is it making symmetric? See, it is not making symmetric because 1 comma 3 is there, 3 comma 1 is not there. That means you have to add 3 comma 1 and you have to add 3 comma 2. Now, don't bother about the transitivity because they are not talking about. So, what are the new things you have added? 3 comma 2. Just you see where it is 3 comma 2 is present. Anywhere 3 comma 2 is present. No, 3 comma 2 is already there. Sorry. I need to have 2 comma 3. So 2 comma 3, then 3 comma 1, and then 1 comma 1, 3 comma 3. Yes, option C. So option C, these four ordered pairs are to be added to the given relation so that it becomes reflexive and symmetric. That is option C. Fine. Oh, that's a good problem. That's an important problem. See that? And really you can understand this. This is I don't want to say that it is a critical problem, but it's a problem. It's a very nice problem because you can see if you observe, if you think about the application of integration, you can find from that only that this part represents the circle of radius 2 and the interior, right? So it is a very good problem. So see, it's an integrated problem actually. We are bringing inequalities here in the relations. Anyway, it is given that R is the relation where X and Y you have to find, and of course that should be integers. And the conditions to be satisfied is x square plus y square should be less than or equal to 4. Then the relation on the set Z. For this, what is the domain? Domain means those which are the inputs. Fine, we'll be trying now. Our conditions to be satisfied is this less than or equal to 4. Now they are talking about x and y to be integers. Acha, if x and y are integers, what do you think? X square plus y square will be integers only. So which particular values you will allow? X square plus y square can be 1, right? X square plus y square can be 2 as per that given conditions. We'll see whether all are possible or not. And then this. Now one by one, let us see. If I take x square plus y square equal to 1, can that be possible? Can there be some values? I can put x equal to 1 and then y equal to 0, right? So let us just try to see the domain. Domain, what will be included? So I am taking 1, 1 can be included. Yeah, I can reverse their role also. I can write x equal to 0, y equal to 1. I mean, I can take 0 for the domain. Good, great. Now they are talking about integers, so negative numbers are also allowed. Can you take x equal to minus 1? Yes, why not? Then this is 0. So minus 1 is allowed. Good. So for x square plus y square equal to 1, I get these three numbers 0, 1, and minus 1. X square plus y square equal to 2. Just give a try. You will not get any integers which will satisfy this. You give a try. Then last one is x square plus y square equal to 4. So very clearly one observation you can make, x equal to 0, then y equal to what? 2. Even x equal to 0, y equal to minus 2 will also work good. But anyway, I'm interested in the x because x is value of x is constituting the domain. So 0 is already there. So now I can reverse also. I can put x equal to 2, y equal to 0. So 2 will come and minus 2 will come. So here you can see clearly that B is the answer. Domain of this relation is B. Many times students might be missing. They might not write the minus numbers. So be very alert about that. This is a very good question. Option is B, as I mentioned. Okay. Now this is depending totally on the formula already I wrote. what is the question here? They're asking you to find the number of reflexive relation on the set A where A contains only two elements. So the formula was what? 2 into n minus 1. N means 2 and then 2 minus 1. So it is 2 square, that is 4. So your answer is 4. It's direct formula, right? So if you can remember, you can do it. So option is B. Fine. Now we have finished with the MCQs. There are a lot many MCQs. I have taken those MCQs which are set in the board exams and which can be giving you a good idea of different types of questions. Other questions will be repeatedly of this kind only. I'm talking about the MCQs. So now let us move for the assertion region question. You already know these conditions, so I don't have to read it. Of course, I have just collected here only one assertion region question for this session. I'll be picking up more. This is the question which is set in 2024. And of course, very less questions are in assertion region from this chapter, a relation. There are some questions from functions, not from the relation. But anyway, whatever we have, let us try. Assertion. What is the assertion statement? The relation R, which is written as x plus y, x comma y, they're related if x plus y is a prime number and x and y are natural number, is not a reflexive relation. Acha, what is the set where you are defining this relation? That is natural number. Okay. To be reflexive, what I should get? I should get every number should be related to itself. So just check whether every time it gives you a prime number or not. If not, it will not be reflexive. So very clearly, I can say 1 comma 1 belongs to R. Why? As 1 plus 1 gives you 2, which is a prime. Let's just take 2 comma 2. 2 comma 2, 2 comma 2 doesn't belong to R. Why? As 2 comma 2 is 4 and is not a prime. We're not writing the statement completely because it is not required for MCQs or assertion region. You need to only answer it. So that means this is false, right? Now you see there is a clever idea. If it is false, if the question is of course correct, then the other one has to be true because the four options is not containing both the option false. So it has to be true. You justify, of course, you can justify also that the number twice n is composite for all natural number. Sorry. I take my words back. Actually, I read the first question wrong. It is about not reflexive. Not reflexive means it will be true. Not reflexive means it is true because we have found that it is not reflexive. So this is true and this is false. Kyuki twice n, they have said that twice n is always composite for every natural number n, but it is not so. Right? Because if you put n equal to 1, you will get 2. That is not a composite number. So this is false. That is true. So this is the option C. C is the correct option for this particular question. C is the option, right? It's a good question. Now next, we are going to have the questions which are either short type, short answer type or long answer type. So we'll be doing, it will take a little time. So have patience and keep on going. It is a question from 2024, right? That is the last years. I'll try to make it short. I'll avoid statements. I'll basically discuss the concepts. You try to add the statement from your side. Okay. Relation R on the set A. A is containing 1, 2, 3, 4, 5. And this is the condition, right? That means X and Y, that ordered pair is not written here. They will be related if x square minus y square is less than 8. Modulus of this. check whether this relation is reflexive, symmetric, or transitive. Believe me, when they will give you for checking, you try to find the counter examples instead of proving it. Counter examples means one example which will show that it is not true. So your task will be easier. Fine. Let us just see. Let us try to start with the biggest and the smallest. Kyuki for the biggest and the smallest gap will be more and that will be better for us. Let us just try to see. No, it will be reflexive. It will be reflexive because for reflexive x square and y square both should be what? Same. X and y should be same, na? So if you can write x square minus y square, for reflexivity, this will be x square minus x square. In that case, only x comma x will come. And this is giving you 0, which is obviously less than 8. So it is reflexive, right? So how can I write? Let me write the statement for you so that you will not be confused. So you have to write this, right? You cannot avoid to write it as these are. So here we can write clearly x comma x belongs to R as x square minus x square is equal to 0, which is less than 8. So we get, therefore, R is reflexive. Done. Symmetric. Okay. Symmetric is very much okay. For x comma y belongs to R, we get, because for symmetric, we have to start with this only. We have x square minus y square modulus is less than 8. So now you can see that inside the modulus, if you change the order and you can make the number negative, magnitude will remain same. That means for symmetricity, it is true. So R is symmetric. R is symmetric. Good. R is symmetric. Now what is left out? Transitivity. Now let us just try to find one example by which we can avoid the transitivity, if it is, right? So I think it may be possible. Let us just try to take, I'm just testing now. I really don't know whether it will be transitive or not. So 1 and 3 and 5 let us take, right? 1 and 3, will they be related? Let us just see. Once this is rough work I'm doing. 1 square minus 3 square. So okay, 3 cannot be related. Cannot be related because it will be 8, right? So just a minute. Let me not take this. I have to just take one by one, not randomly. Otherwise, what will happen? I may not get the answer directly. First, let me try to take two numbers which are related to each other. Say 1 is related to 2. Is it related? Yes. Why it is related? As 1 square minus 2 square. This is equal to 3, which is much more less than 8. So related. Now, which 2 I want to relate something. Let me try to keep a gap of this. 4 if I write, it will not be 3 will be doing, I think, yes. So this will be here as 2 square minus 3 square. That is 4 minus 9, 5. Of course, modulus is there. So this is very much less than 8. But what you can say? 1 comma 3 does not belong to R. Why? As 1 square minus 3 square is equal to 8 and it is not less than 8. So it is not transitive. So here how will write? Now you write like this and then at last you conclude that it is not transitive. So What have you seen? It is reflexive, it is symmetric, but it is not transitive. A very important question. Let's move on to the next. If I am doing it in a hurried manner, pause the video and then note it down. Okay, let's get into the next question. It has been set in 2020. Check whether the relation R in the set n of natural numbers given by R is equal to order pair AB, where A is a divisor of B, is reflexive, symmetric, and transitive. Also determined whether R is in an equivalence relation or not. So, divisor they are talking about. A is a divisor of B. Then A and B are related. So now I have to check the reflexivity. For reflexivity, A comma A should be there. So just let me see. For A belongs to natural number, you can say easily that A is a divisor of A. Is that possible? Yes, it is possible. A is a divisor of itself. If this is happening, I can say A comma A belongs to R. So what is my conclusion? R is reflexive. R is reflexive. Fine. Now for transitive symmetricity, you should start with directly the ordered pair. Now for A comma B belongs to N, I shall start with A comma B belongs to R. Acha, what will it imply? A is a divisor of B. So rather I write like this. A divides B. Acha, if A divides B, will it necessarily imply B divides A? B divides A? No. It is not always. Kyuki, if they are not equal, it is not. Right? It is possible if both are equal. So that means I get BA belongs to R. Here, this is the problem. Many students might write here not belonging to R. Don't write this because I am writing this conclusion on the basis of this, right? The equality or the implications is broken here. So in the entire result, what did I see now? AB belongs to R does not imply BA belongs to R, right? Therefore, R is not symmetric. R is not symmetric. Now think about the transitivity. I think transitivity is very clear. So you write for A, B, and C, A comma B belongs to R and B comma C belongs to R. What it implies? A divides B, I write it like this, and then B divides C, right? Now, see, if you want to make it more extensive, you can do it. A divides B, it means B is equal to A times some integer. B divides C means C is equal to B times some another integer. So overall, what did you see? C is equal to, this B you can replace. So if you replace by AM, so ultimately it is C equal to A times Mn. So what can I say? Uh, A divides C because C can be expressed as product of A and some integer. So it divides, so it is transitive. So if it is transitive, what will be your conclusion? It is an equivalence relation. Very good. Very good. This is an important question. Please try to see. Now, next, check whether the relation R on the set A, which is containing 1, 2, 3, 4, 5, as R equal to AB, A and B are related if B is equal to A plus 1. Okay, few, I think Few minutes back, we have done a problem of this kind. So it will not be difficult. In MCQ, we did. So here, this time it is in the descriptive. It is reflexive, symmetric, and transitive. You have to check which one is true. So let us do the solution. So here, as the set is very, very small, I can easily find the relation. So let me write what is the relation. My condition is what? A and B are related if B equal to A plus 1. That means whatever value of A you choose, B will be one more than that. But you should remember that that should be taken from A. So I can write 1 is related to whom? 2. Then 2 is related to 3. 3 is related to 4. 4 is related to 5. 5 is related to 6. But 6 will not be related to anyone. Why? Because 6 will be related to 7 and 7 is not here in the domain. So I cannot take that. Now from here, it is very clear. It is not reflexive. Why not reflexive? Clearly 1 comma 1 is not there. So this kind of problems are easier. So you can write clearly R is not reflexive as A comma A is not belong to R for A belongs to set A, right? Not for single one it is there. Okay. Is it symmetric? Symmetric for this, you have to get AB belongs to R implies BA belongs to R. So here it is not possible, right? So you can write also R is not symmetric as A comma B belongs to R does not imply B comma A belongs to R, right? For all AB belongs to A. I would like to suggest you one thing. Don't just leave it like this because somebody might think you directly wrote the answer. So you give one example also. Here it is like this, then you write for instance, one example I'll put. For instance, 1 comma 1 does not belong to R. Only one you give. Here what will you write? You can write 2 comma 3 belongs to R, but 3 comma 2 does not belong to R. 3 comma 2 does not belong to R. It's done. Okay. So it's not symmetric. So I'm just writing not symmetric because it is more or like the mathematical part I am doing. Please add the proper statement while doing. Now, is it transitive? Not transitive. Why not transitive? Because if I say 2, 3, and I take 3, 4, 2 is related to 3, 3 is related to 4. To be transitive, I should definitely have to get 2 related to 4. 2 is not related to 4 because 4 is or you can say with 2 you have to add 1, you cannot get 4 because the condition of relation is B equal to A plus 1. So it shows that it is not transitive. So we'll write the answer for this at the beginning. So you can write uh, also R is not transitive as 2 comma 3 belongs to R, 3 comma 4 belongs to R, but 2 comma 4 doesn't belong to R. You can add here at the last moment the actual statement, that is the actual definition, that is A comma B belongs to R comma R comma B comma C belongs to R does not imply A comma C belongs to R as it is not transitive. Done. So you have justified all things. That's it. This is a question, very good question. Now let us come to the next question. Q be the set of rational numbers and R be a relation on Q defined by x comma y, where x and y are rational numbers, and x square plus y square equal to 5. So I think I need not explain it more because one such problem already we have done where it was x square plus y square less than or equal to 4. So they are asking you to check whether it is reflexive. So for reflexive, what you should get? One element should relate it to itself. So here it is Q. X and Y should belong to Q, means rational number. So if you take two rational numbers, can there be two rational numbers which are such that x square plus y square equal to 5 always? Because there are many rational numbers, right? There are many rational numbers. Let us just, let me not speak more. Let us try to do it, right? Now, for x comma x belongs to R, for we are going against. Let us see whether it is possible or not. For x comma x belongs to R, we must get what? X square plus x square equal to 5, and then twice x square equal to 5, and then x square equal to 5 by 2, and that will imply what? X equal to plus or minus root over 5 by 2. I mean, this will be true for only this possible value of x if you talk about the reflexivity. But this value is not rational, it is irrational. That means I cannot get. So you're right, this is not belonging to this. Therefore, R is not reflexive. Reflexive नहीं हो सकता है. Symmetric. Symmetric is possible. So you just identify one order. So how I can do it? For x comma y belongs to R, we get, what do we get? X square plus y square equal to 5. Suppose that we get to the rational number. Yes, you can get, of course, by trial and error also. 1 and 4 you can get. Even other rational number will be there. I'm talking about 1 and 4. Sorry, 1 and 2. 1 square plus 2 square. So if this is happening as addition is commutative, I can even write like this: y square plus x square equal to 5. So that will definitely imply y comma x belongs to um, yes, R. So it is symmetric. R is symmetric. So you got R symmetric, not reflexive. Now the last one, it should be transitive. ये तो transitive नहीं होगा. क्यों नहीं होगा? Okay. So first you have to identify two uh, values which are related to each other under this. So we'll write, let us just try to see. Or let us try to solve it, right? Logically. For x comma y belongs to R, y comma z belongs to R, we get, what do we get? X square plus y square equal to 5, y square plus z square equal to 5. Now, from here, can I get x square, sorry, x square plus z square equal to 5. Let us see, let us add it. Now, if I add, I get x square plus twice y square plus z square equal to 5. Let us just see, can we get some rational values? So let me just write this equal to 5 minus twice y square, right? No, this will not be 5, this is 10. Yes. So now, if x square plus z square will be 5, then only you can say x and z will be related. when it can be 5. To get x square plus y square, sorry, x square plus z square equal to 5, I must get this value equal to 5. That is twice y square must be 5. Now just justify. Twice y square, can it be 5 for any rational value of y? Not possible. Why not possible? Because if you try to find what is y by putting this equal to 5, you will be getting this value, right? Already you have done. That is the basis. So I can write, uh, I can write like this. This after that, what to write? My space is less, so you try to adjust it. For x comma z belongs to R. For this, we must get what? I'm telling the statement you write. We must get x square plus z square equal to 5. So we must get twice y square equal to 5. That is y equal to plus or minus root over 5 by root over 2. Is it possible? No, it is not possible. So if this is not possible, that means it is not transitive as well. So overall, what did you see? This is not reflexive. This is not transitive. This is only symmetric. It's a very good question. Okay. So let us go for the next question. There are few more questions. It is a little longer because it is one shot, right? So please go through it. Bear me. Take your time. You see in parts and let me complete in one shot. This is a question in 2020. It's a very important question. And let me try to tell you that this question is not there in the textbook of ours. So what is there? Let n be the set of natural numbers and R be the relation on n cross n. Okay. Earlier you had relation defined on a set, single set. In that case, your elements were A, B, C type. But this time it is on n cross n. So your element will be taken as ordered pair. Be very clear about that. For example, see, earlier we have taken, just a minute, we have taken this as an element, this as an ordered pair for the relation. But this time this A comma B will work as a element of the set because relation is defined on the set n cross n. So now you have to show that this is an equivalence relation. So first I'm doing it, right? Here R, in R I should relate the elements. See, this element is related to this element. Can you make a difference? Earlier you have got A and B here. But this time A comma B itself is one element. Such that what is the condition? They have already given it is AD equal to BC. That means first to last product must be equal to product of the between. And then A, B, C, D are the element taken from natural number n. Now reflexivity, let us see. For reflexivity, first two elements would be same. If it is, then we are done. Right? So now we'll write. Now for AB belonging to n. Just let us see. We start from the back side, okay? For that, you do a rough work. My elements should be what? A comma A related to A comma A. So I should get A times A, sorry, A times B equals B times A. Is it possible? Is that true? Yes, it is true. So if this is true, I can say from here A comma B, right? A comma B and A comma B. I'll put a bracket is related to itself. So what I can write? Therefore, R is reflexive. R is reflexive. Please try to see what I did. Actually, I tried to go from the backside. I tried to see first that condition, right? So that is very important. This is a way of doing. This is a rough work. This is only to see which particular order I should multiply. Now symmetricity. Symmetricity will be easier, right? For I should take two elements, these elements in n cross n. Remember it. For symmetricity, what should I start with? They these elements to be related, so they are related. Now where should I end with? I should get these elements swept. That means C comma D should be in the first place, A comma B in the second place. So let us just proceed. See, I'm giving you a trick here. So if I am getting this related, so I should get what? A times D equals B times C as per the given one. Now, after applying this, I should get what? I should get C comma D here and then A comma B here. And I know that this will be related, right? So this intermediate step you fill up from the backside and you will see that it will be adjusted. So what is the condition? If these two elements are related, product of the ends, that is C times B must be equal to D times A. Now just you see, is this giving you the relation? Obviously. BC I can write as CB, AD I can write as DA, and then I swap this. So now it is clearing you. So you can think like this, that this is implying that, this is implying this, and therefore it is implying that. So what is the conclusion? Therefore, R is symmetric. Right? Now the last condition. It is transitive. So for transitive, I am going for the next page. So for transitivity, I should start with what? Now, AB related to CD. That means this will be in the ordered pair. And then CD should be related to the another element. E I will not take. I'll take FZ as the next element. This is belonging to R. Now let us see what will it give. If these two are related, what I get? AD equal to BC. Here what will I get? CZ equal to DF. Right? Now stop for a while because you have to adjust. Otherwise, you may not get a chance directly to do the problem in the single shot. What should I get ultimately? You try to do it in the rough. I should get A comma B related to F comma Z. If I need to attain this, what should you have? A comma Z, sorry, A into Z should be equal to B into F. Now you have to do something here so that you get A into Z equal to B into F. If you can get it, then that will be related. So, yes, let me multiply this, right? Both the equations I want to multiply. So equations can be multiplied. So I'll multiply AD into CZ. This equation is multiplied with this. So left side is multiplied to left side. And then BC will be multiplied to DF. Now you can see here, something will be cancelled. Which will be cancelled? C is cancelled out. D is cancelled out. So here you get A times Z equal to B times F. And that's exactly what your rough work was showing. If you get this, you can get back to that. So you can get A comma B belongs A comma B comma F comma Z. This ordered pair belongs to R. That means they are related. So what did you observe? This related to this related to this. Ultimately, first and the third related. You write a compiled conclusion statement. I am directly writing Therefore, F is transitive. If F is transitive, overall, what did you notice? It is reflexive, symmetric, and transitive. Therefore, R is equivalence relation. It's again a very important question. It is one of the probable questions, so do practice it. Okay, so pause the video and try to understand it. Let's go for another important question. Yes, this is also a question which is set in 2024, and see the things. It's more or less same type, only it was there A into D. Here it is not into D, it is difference. Right? So we'll try it, no problem. So this time I'll not write the statement. I'll just show you the mathematical calculations. Please add the statement. So first of all, I have to show what? Again, I'm doing the rough work. I have to show that AB should be related to AB. So I should get the difference. You see the pattern, how the differences are done. Difference of first two and difference of the second two. So here A minus A. So you will write like this: for A comma B belongs to N, you can write A minus A, which is 0 and is equal to B minus B. Right? So now you see, if you apply this condition here, you should get this. So it means if you get this, you can say that this will be obtained in the reverse direction. So you can directly write that this is related to AB. How you will manage it? By putting a comma belonging to R. So what you will write, therefore R is reflexive. Fine. Symmetric is always easy, but let us do it. For A comma B and C comma D, for symmetric, I should start belonging to this. What should it give you? A minus C is equal to B minus D. Okay. Again, I am telling you, do the rough work. I want to get the result as C comma D related to A comma B. So what shall I get? I should get C minus A equals D minus B. Can I get from here? Yes, nothing is there. Just you reverse the order, right? Reverse the order, or you can say transfer the terms from one side to another side. So this is immediately giving you C comma D and A comma B related. So what will be your conclusion? R is symmetric. See, these are easy questions, but if you don't practice in exam, you may be in a problem. Good. Now, what is the last part? Transitivity. Good. Let's do transitivity as well. So here for transitivity, I need three ordered pair, right? Sorry, it is not BC. Just a minute. I need another ordered pair, no? This would be different ordered pair. So it is, oh, just a minute. I'm making a mistake. It is C comma D, another ordered pair, and then F comma Z. These are the ordered pairs in N cross N. Now, for transitivity, you will relate the first two ordered pair. You will relate the second two ordered pair. And then this should imply the first and the third. So let us just write the relation. How did we write the relation? A minus C equal to B minus D. And here C minus F equals D minus Z. Now again I will tell you, I'll propose you to do the rough work. What should be your final relations? AD and AB and FZ. So where you should end up? A minus F you should get equal to B minus G. Just you see, can you get this? Yes, I can get it. How you can get it? This time addition you do. Previously we did multiplication. This time addition will do. If I add these equations, you can see what will happen. B minus D plus D minus Z. Okay, this is getting cancelled, this is getting cancelled, and very obviously you are getting this. And now you see, if you get this, you can get back this to that. So AB, and then this is F comma G belongs to R. So that's it. Therefore, R is transitive, right? So it's a very important thing. I hope you have understood it. Repeatedly, I am saying, pause the video, check it once, do more. Oh, see, dear students, here I'm not going to complete this problem. I'll leave the hints. You try to proceed. I'm leaving the hints because if you try to work with directly with this expression, it may not be very helpful for you. It may be confusing. So I'll be giving you a step where you can justify. So I'll modify, right? At the beginning only, just you start and modify this relation. You really should not work with this relation directly, right? If you start working with this, it may not be able to give you the answer. So what you'll do, you do one thing. B plus C you keep this side, then BC you bring here, and then A plus D you keep here, AD you bring down. What I did, I divided, or I can say that AD I have brought down, BC I have brought down. So now if you divide, you will find this as 1 by C plus 1 by B, and this is 1 by D plus 1 by A. That's it. So now relate these things with this. How you relate? A comma B is related to C comma D means reciprocal, sum of the reciprocal of CB. CB means these two in the reverse order, right? Reverse order. If you want, you can do one more thing. Let us do that more easily. Maintain the order. BC, and this should be written as 1 by A plus 1 by D, right? So in that case, try to see which particular order is going where. If I say AB is related to CD, then I should get reciprocal, sum of the reciprocals of the interior two numbers, inner two numbers should be equal to the sum of the reciprocal of the outer two numbers. So now the rest of the work is yours. Just I'll show you the calculation. The first will be your AB to be related to AB. So what should you get? A 1 by A plus, uh, sorry, 1 by B. 1 by B should be equal to 1 by 1 by A, yes. 1 by B and 1 by A should be added, and that should be equal to sum of the reciprocal of this. And if you get this, you can get back to this. So this is true already, right? Symmetricity will be very easy. Transitivity also will be done in a similar way. I leave this for you. You please mention in the comment if you need the proof of this. But I think after this you can do it. But this is a very important problem. Please see that. This is another important problem. I have seen students committing mistake here when it was set in 2024. There are many brilliant students who missed it out. So I'm going to do it. It is to be done completely. Hmm? So here I would like to propose you one thing. If somewhere you find a question where somebody mentioned that check if it is this, check if it is that, then always try to first look for the negativity. It means think that it is not true and try to find the examples. If not, then only you proceed for the proof, right? So here they have said check whether the relation S in the set of real numbers defined by S ordered by A comma B. That means A is related to B, where A minus B plus root 2 is an irrational number. Is reflexive, symmetric, or transitive? So at the beginning, my mind should think, okay, can I find examples so that I can show it is not reflexive, not symmetric, not transitive? If it is possible, okay. Otherwise, I'll try to prove it. So for being reflexive, both A and B should be what? Same. So if A and B are equal, they will get cancelled and you will be left out with root 2 always. And it is an irrational number, so it is reflexive. Very clearly. So you can directly write for A belongs to R, A comma A belongs to S. Why? As A minus A plus root 2 is equal to root 2 and is irrational, right? So you directly get it. Therefore, S is reflexive. Okay. Now symmetric. Is it symmetric? This is a trick question, right? If you say A minus B, so if I rotate it or flip it, B minus A, root 2 will be there. So it will be symmetric like this, you might think, but it's not the case. Think about this. How we'll do this, right? So let me first go for the counter example here, then I'll write the statement. Okay. So what I want to say, or you can write like this also. If suppose, now think in a negative, you have to make this entire quantity a rational number after exchanging A and B. After exchanging A and B, that means in place of A, you should write B, B in place of B, you should write A. So how will write, you see? This is root 2, right? And then this is, okay, comma, B equal to 1. I can take A equal to root 2 because I have to take A from the real numbers, right? B equal to 1. If this, this value will be what? A minus B plus root 2 will be root 2 minus 1 plus root 2. That means 2 root 2 minus 1. And it is irrational. So if this is irrational, by my definition, I can say that this is in the relation S. It is in the relation S. So it is okay, right? But if I need to talk about B comma A, I should write it like this. You now try to put the value. B is 1, A is root 2, so it will be like this. So what you get? This is rational. So if it is rational, you will say that B comma A doesn't belong to S. So what is your conclusion? It is not symmetric. That's a very important part. Right? Many students wrote it as symmetric. That's what the common mistake you do. So I write that S is not symmetric. Now, what do you think? It is transitive? I hope it is not transitive as well. Let's try to see. I'm not sure right at this moment. Let us see. So for transitivity also, we'll try to identify some steps. Okay, I don't have space in the next slide, so I'll remove some of them. So pause and then you can write, no problem. Let me remove this and let me check whether it is transitive or not. For transitive, what should I get? A comma B related, B comma C related, and A comma C should not be related. So as per that, can I get examples? Let's see. I'll just try to plan it. It's a rough work. After that, I'll write it in the fair. So I'm writing here. You should do it in the rough in the actual practice. I should get this to be irrational. I should get this to be irrational, but I should get this to be rational. It means that somehow this root 2 should be cancelled. So try to adjust it. So let me just try to take C as root 2. Okay, C as root 2. I have got it. Great. This is already root 2. If I write C root 2, they will be getting cut. It will not be rational. So it means you have to choose a B in such a way that this will create a irrational quantity. So let us make it uh, easier, right? Let us make it little easier to root. So root 2 and minus root 2 got cut, and this entire sum is 2 root 2, so it is irrational. That means B comma C will be belonging. Okay. Now this is 2 root 2. So it is plus root 2, this is minus 2 root 2. So, and this quantity is still giving you minus root 2. So irrational to ho gaya, right? You can take any rational number here, right? So what did you observe this? It is irrational. That means A comma B belongs to R, B comma C belongs to R, whereas A comma C will not belong to R because if you write this expression, it will be a rational one. So how will start with? I'll not write the complete statement. I'll tell you verbally. You write for A equal to 2, B equal to 2 root 2, and C equal to root 2. A minus B plus root 2. You find a value and say that it is irrational. This is irrational, but A minus C plus root 2 is irrational. Therefore, A comma B belongs to S, B comma C belongs to S, but A comma C doesn't belong to S. That's it. So it is not transitive. Good. Now this is the last question, and I think I need not complete it because this is a question from the book. I took it because I wanted to show you that this question is repeatedly coming. It is earlier also I mentioned in MCQ, then one question in short answer type, and this is long answer type, right? So it is a question from the book. So obviously I need not do it. So it is a multiple of 4. It is an equivalence relation, right? So what they are asking you, see now, find the set of all elements related to 1. Actually, we have done this earlier, 159, you can remember that. Then they are asking you to find the equivalence class containing 2. So that means set of elements related to 2. Let us try to write this directly. 2 will be there because 2 minus 2 is 0. 0 is divisible by 4. Fine. Then 6 will be there. 2 minus 6 is minus 4. Modulus is divisible by 4. Then 10 will be there. No more. Because after that you will get 4. 14. 14 is not here. So this is the set. That's it. So today I'll finish with this question here. It is on the relation. So we'll take in the next video the function. By that time, please do practice it and select those problems, the last bigger problems, which are very important. Practice it. All the best. Bye bye.